Welcome back. In this video we're going to look at the relationship between the frequency of some form of electromagnetic radiation and the energy that that radiation possesses. Back at the beginning of the 20th century, a German physicist named Max Planck discovered this relationship, that it was a direct relationship that as the frequency of radiation increases, the energy also increases. So for example, if you know that the frequency of blue light is higher than the frequency of red light, then you also know that the blue light has more energy. So for that reason, blue fire, or fire that's blue, is actually hotter than fire that's red. So what he did was he measured the energy of each form of radiation, and then when he was able to take that energy and divide by the frequency, he found that he always got the same number. Every time that you take energy divided by frequency, you're always going to get what is now called Max Planck's constant, which we show as an H, and it's 6.63 times 10 to the negative 34 joule seconds. So you can use this constant in order to find the frequency or the energy if you have the other. So here's an example. Electromagnetic radiation with a wavelength of 465 nanometers appears as blue light to the human eye. The energy of one photon of this light is how many joules? So if we were given the frequency, we could simply just multiply by Planck's constant and we would have the number of joules in energy, but we're not given the frequency, we're given the wavelength. So we have to use the other formula from this chapter, which was the speed of light formula, in order to determine this. So if you're given the wavelength, you can't put it directly into this energy equals h nu constant relationship. You're going to have to go back to the other one first. So if you remember, speed of light is lambda nu. Lambda is the wavelength. Nu is the frequency. So since the speed of light is a constant, it's always 3 times 10 to the 8 meters per second. The first thing we need to do is take this wavelength and put it in meters so that the meters will cancel in this formula. So we know that there's 1 billion nanometers in a meter. So 465 nanometers divided by 1 times 10 to the 9 gives you 4.65 times 10 to the negative 7 meters. So once I have that, I know that C is 3 times 10 to the 8 meters per second. I know that lambda is 4.65 times 10 to the negative 7, so that I know now that my frequency, nu, is 6.45 times 10 to the 14th second to the negative 1, or cycles per second. So now I can take that and put it back in the original formula, E equals h nu, and h is going to be 6.63 times 10 to the negative 34. Frequency in our case is 6.45 times 10 to the 14, and so when you solve for joules you get 4.27 times 10 to the negative 19. Okay, thank you. I hope it helps.